Let's do a little reminder on what makes a relation a function. So in order for a relation to be a function, every input can only have one output. So we're looking at our inputs here. We have 8, 4, 2, 4, and 8. So our 8s repeat themselves, and so do our 4s. So our 8's confused. It doesn't know if it's supposed to go to -4 or to +4. And our 4's confused too. It doesn't know if it's supposed to go to +2 or -2. So this one would not be a function because the input 4 has more than one outputs. Let's skip down to number 5 because it's similar, but these are ordered pairs. So remember the x value of your ordered pair, so it goes x, y. The x value is your input value. So if we're looking at those our input values, we have -3, -1, 0, -1, and 2. Well, all of them are good except -1 doesn't know if the output is supposed to be 8 or 2. So this one also is not a function, just like number 1. But if we're looking at a graph like number 3, our strategy is to use the vertical line test. So you see, is there a vertical line that as you move it across this graph, would it ever hit more than one point at the same time? And the answer here is no. So no matter where you draw your vertical line, it's only going to hit one point at a time. So because it passes the vertical line test, this is a function. So let's continue on this page. I'll do 7 and 9 on this video as well. So for this section, we're deciding if it's a function or not. So that's what we just did in 1, 3, and 5. So these are all graphs though. So you're going to be using the vertical line test on all of these graphs. So looking at number 7, we've got 5 points. None of them would fail the vertical line test. So it is a function. And then obviously for number 9, it's a straight line. This is linear. So it is a function. And to tell whether it's discrete or continuous, that's when we ask ourselves, could our domain be fractions of numbers? Is it very specific numbers, or can it be everything within a range? And when I say range, I mean like within a value set. So in this place, we have random points all over the place. This is discrete because it's just very specific points, but continuous would be number 9 because every number from here to here, from 0 to 6, is included. So this would be continuous. You would never be done listing all the points that are contained by that segment. So then when we're finding domain and range, remember your domain, those are your x values. The range, those are your y values. So if it's a discrete function like number 7, our domain and our range is just going to be a list of points. We're just going to list all the points that make up our domain and all the points that make up our range. So this one has 5 points, so we can have up to 5 numbers in our domain. So this point is at -3, that's its x value. This point is at -1. The x value of this point is 0. We have 1, and lastly 3. So our domain is made up of -3, -1, 0, 1, and 3. Our range is our set of y values, so we're going to do the same thing. For each point, we're going to see what the y value would be. So for this point over here, the y value is 2. And actually, it's 2 for this point as well. For these 2 points down here, the y value is 0. And for the one at the top, it's 3. Now, when it's a continuous function, because you can't name every single point that's on that line, instead we write them as an inequality that looks like this. So our range is our y values, our domain, our x values. We clearly have closed dots here, so we're going to have all equal to signs underneath. So our x is looking from left to right. Where does it start and where does it stop? So this graph starts at 0 and it travels, travels, travels. It ends at 6. That's its definite stopping point. So our domain is every number between 0 and 6. To find our range, we look up and down. So the range doesn't start at 0. The graph doesn't start going up and down until at 20. So the lowest y value is 20, and then it goes all the way up to 60. And that's how we would find domain and range.